Hello friends, welcome back to the amazing Word of Edupedia Word videos. In this video, we'll be dealing with some questions on common trigonometric ratios, that is, angles involving 30 degree, 60 degree, and so on. The first question says, find the value of the given expression. 2 tangent square 45 degree plus cos square 30 degree minus sin square 60 degree. Friends, it is very important to memorize the individual values of these terms or trigonometric ratios by this table. Let us find out the values we need to know for this particular question. First of all, we need to know tangent 45. Tangent 45, my friends, is 1. Thus, the value of tangent 45 is 1. Cos 30 degree and sin 60 degree are two more values to find. Now cos 30 degree is under root 3 by 2 and sin 60 degree is again under root of 3 by 2. So the quotient given will get converted to quotient equals 2 tangent square 45. I have earlier told you is nothing but tangent 45 whole square. So it will be 1 square plus cos 30 degree similarly under root 3 by 2 whole square minus sin 60 degree whole square, that is under root 3 by 2 whole square. So it becomes 2 into 1 square, that is 1. So 2 into 1 will be 2 plus under root 3 by 2 whole square, that is under root 3 whole square over 2 square minus under root 3 square over 2 square. So it will become 2 plus 3 over 4 minus 3 over 4. These terms get cancelled because of being of opposite signs, so we are left with only 2. So the value of the given expression is 2 as the answer. Let us deal with another question. In this question, we need to know the value of sin 30 degree, tangent 45 degree, and cosecant of 60 degree, secant 30 degree, cos of 60 degree, and cotangent of 45 degree. So sin 30 degree is 1 by 2, tangent 45 degree is 1, cosecant 60 degree is 2 by under root 3, and secant 30 degree is 2 by under root 3. Cos of 60 degree is 1 by 2 and cotangent 45 degree is 1. Friends, you can easily remember these two values, that is tangent as well as cotangent of 45 degree is nothing but 1. So it is very easy to remember. So our expression becomes 1 by 2 plus 1 minus 2 over under root 3 over 2 by under root 3 plus 1 by 2 plus 1. So taking the LCM, we get in the numerator 2 by under root 3 as LCM, and this part will be multiplied by under root 3, so 1 into under root 3 plus this as having denominator as 1, so 2 into under root 3 will be multiplied by 1, and similarly minus of 2 and the residue of the LCM, that is 2, will be multiplied by this. Similarly, in the denominator, the LCM is clearly 2 by under root 3, and the values changes to 2 into 2 plus, here we will get under root 3 and here 2 under root 3. So the quotient gets converted to under root 3 plus 2 under root 3 minus 4 over 2 by under root 3 over 4 plus under root 3 plus 2 under root 3 over 2 under root 3. So these two have same radicals as under root 3 and under root 3. We can take under root 3 common and are left with 1 plus 2, that is, the answer is 3 under root 3. So numerator becomes 3 under root 3 minus 4 over 2 by under root 3, and the denominator part, this part becomes 3 under root 3 for this and plus 4 over 2 under root 3. Friends, if we have a condition like x over y over z over p, then to convert this into fraction, that is numerator or denominator, it get converted as x over y into p over z. That is, this part will go to the topmost part and this part will be multiplied by this denominator. So here what we are left, firstly this part as it is as 2 over under root 3, and this part, the second lowest part, will be multiplied by this denominator, and this particular part will go on and multiply with numerator. So this part can be cancelled by 2 by under root 3, 2 into under root 3, and we are left with 3 under root 3 minus 4 over 3 under root 3 plus 4. Friends, we can never have, an under root term in denominator for a proper fraction. So we have to rationalize this denominator. So rationalizing the denominator, what can we do to rationalize this denominator? Friends, the only culprit here is this under root term. So we can cancel this under root term by multiplying this, say, under root 3 by some under root 3. Friends, if we multiply 3 under root 3 plus 4 by under root 3, we will no doubt cancel this term as 3 into under root 3 into under root 3, that is 3 into 3. This product will become 3, so 9. But on the other hand, 4 will include this under root of 3. So we are removing one culprit, and on the other hand we are adding another culprit. But say if we are multiplying this by some variable, that is this constant, so in this case it will become a plus b whole square. So by using the identity, it will become 3 under root 3 whole square plus 4 square plus 4 into 2 into 3 under root 3. Again, no doubt this will get cancelled, the under root part, and this will also, the term will not be having any under root part, but this term will be having this under root part, because 4 into 2 is 8 and 8 3 is 24. So under root part will again be prevailing in this particular term. Now see, square has the square part, that is a square plus b square, has helped us to cancel this under root part, but due to of 2 into a into b, due to 2ab, the b or a, that is 3 under root 3, has prevailing here, and the under root 3 part is not cancelled. But friends, we have learned an identity that a plus b into a minus b equals a square minus b square. Here we are only having square parts and no part like 2 into a into b. So this will this identity will solve our problem. That is, if we multiply both the numerators and denominators by 3 under root 3 minus 4, then it will become a plus b into a minus b. Now a plus b into a minus b whole square is a square minus b square. So at denominator we will have 3 under root 3 whole square minus 4 square, and on the numerator we will have 3 under root 3 minus 4 whole square. So if we solve this part, the denominator, we will get 3 into under root 3 whole square, that is 3 square into under root 3 into under root 3, or 9 into 3, that is 27. So 4 square is 16, and at the numerator we have a square, that is 3 under root 3 whole square, plus b square, that is 4 square minus 2 into a into b. That is, at denominator we have 27 minus 16, that is 11. The numerator, this part is 27, and 4 square is 16 minus 2 into 3 into 4, that is 4 3s are 12, and 12 2s are 24, so 24 by under root 3. So friends, we have successfully resolved the issue of under root term at the denominator. One more thing that should be cleared is that we can multiply same term at numerator and denominator to have the equivalent expression, because say we have 4 by 6. Now multiply same value, say 6 over 6. This will have no effect as such, because if we cancel this term, this will again be 4 by 6. So we can only multiply same term at numerator and denominator, and not the different terms, which we have done here. That is, same term is multiplied here. So on solving this, we get the result as 43 minus 24 under root 3 over 11 as the solution of the given identity or equation. Let us have one more question. The question says, if tangent of a plus b is under root 3 and tangent of a minus b is 1 by under root 3, where the sum a plus b lies between 0 and 90 degree, find the values of a and b. Friends, we have tangent of a plus b is under root 3 and tangent of a minus b is 1 by under root 3. Now, if an angle has the value of root 3 in tangent, then this angle is 60 degree, and if so, it is 60 degree. That is, this particular angle a plus b is 60 degree. On the other hand, if we have 1 by under root 3 as value, then the angle is 30 degree. So this angle is 30 degree. So our equation or the question reduces to a plus b is 60 degree and a minus b is 30 degree. So now if we add, friends, the given question has been reduced to a pair of linear equations if we look at these equations closely. So by any method, say elimination method, first add 1 and 2 and then subtract 1 and 2. On adding, we get 2a and b minus b, that is 0b, equals 60 plus 30, that is 90 degree, or a equals 90 divided by 2, that is 45 degree. If we subtract 2 from 1, then on LHS we have a plus b minus of a minus b equal to 60 degree minus 30 degree. So a plus b minus a plus b equals 30 degree, that is 2b is 30 degree, or we can have B as 30 degree divided by 2. Now 30 divided by 2 is 15 degree. So all in all, we have A as 45 degree and B as 15 degree. So friends, these were some questions on the common trigonometric ratios like 0, 30 degree, 45 degree, 60 degree, 90 degree and so on. Thanks for watching this video.